Well, hello everyone. Very good afternoon. I hope everyone is doing okay and are well at their respective ends. I think we can wait for a couple of more minutes for people to join in there. I still see a few notifications of people joining in. So I'm just going to wait for a couple of more minutes and then we can get straight away started with our webinar. So, guys, before we actually start, if anyone has a particular question or would like to have any interesting thoughts on the role of AI and machine learning into architecture, please go ahead. We'd like to hear. I mean, I believe everyone would like to hear from you. So the stage can be shared by everyone. That's the whole intention of this webinar. We are trying to create a community over here. So I think that's the bigger picture. Please feel free. The stage is definitely can be shared with everyone, and also the team is going to share one of the links on the chat box, which is going to be the WhatsApp link for you guys to join in. We will be sharing a couple of things uh, post the webinar, the things that we will be doing during the presentations. I will be showing you a couple of scripts and some of the slides I would like to share with you all. Uh, in that case, it'll be great if you can join in the WhatsApp group. Please do put down your names and your mail address on the chat box. Make sure you put down the same name that you have used to probably the username that you have used while registration, so that we can keep a track of it and we'll create another batch out of it so that we can share all the references or things that we have with us with you all. um, yeah, so make sure please do check the link, uh, put down your names, your mail id, and I think in another a minute or so we are all set and we are set to go. Okay, so you actually have to put down your ID and your details in the chat box. Okay, use the Google chat box to put down your mail address. Okay, I think that's about it. It's the show time, I believe. So yeah, please drop your name and email ID in the chat box. Yeah, someone from the team will definitely connect you, and we will be sharing the WhatsApp link as well. Just click, and you will automatically be part of the group, part of the community, I would say. Okay, so once again, to everyone who are here, very good afternoon. I hope everyone is doing okay and are well at their respective ends. My name is Piyush Prajapati. I'm an architect and computational designer currently working in Dubai. I would like to thank Equim for organizing this, for this opportunity, I would say, to have conversation with you all. I feel it is a very great initiative to keep us all connected during this time of pandemic. And I sincerely hope this webinar would help in bringing some fresh and new perspective towards design and architecture. So today's topic of discussion and webinar is architecture of intelligence, identifying the importance and the role of AI and machine learning in architecture. So before we dig in deep into artificial intelligence, I would like to highlight on the timeline of AI architecture with respect to design invention, design theories, and design innovations. So in the year 1930, the era of modularity came into picture, where we saw few amazing concepts and designs. The very first argument on smart architecture was stated by Walter Gropius, where he spoke about using computers in architectural design. And soon after that, we came across the modular system of anthropometry by Le Corbusier in the year 1945. A very interesting inference is that by unifying both the ideas and concepts, Moshe Chavde designed Habitat 67 in Montreal, in Canada. I'm sure housing complex is so famous that every architecture or the design students must be aware of it. But the Dartmouth Summer Research Project was basically an artificial intelligence boot camp, which was there for like 6 to 8 weeks, and it is known to be the pioneer, and it was probably one of the starting steps of artificial intelligence into the world. Okay, before I take through the timeline again, I would like to ask you all how well are you aware of artificial intelligence in architecture? Have you guys been using some of the softwares like Dynamo or Grasshopper in your daily life, in your projects, in your designs, etc.? If yes, please just comment what's the status or how well are you aware of these softwares? Are you beginner? Are you probably advanced level? Are you in advanced level? Or are you at pro level? It'll be great for me to understand your perspective. What are you expecting from this webinar as well? So I can probably sculpt the whole webinar accordingly. So make sure you just type it down on your chat box. Just let us, myself, and the team know about your level of understanding about AI, which is artificial intelligence in architecture, and we can take it forward. So we spoke about the phase of modularity. In the next phase, 1960 onwards, the era of computational design emerged, where we saw inventions of the sophisticated computer programs such as AutoCAD and CATIA by Frank Gehry, uh, which is also recognized as Gehry technologies these days. So, and the Christopher Alexander spoke about the pattern language in architecture, and MIT came up with the first ever chatterbox in the year 1966. Well, to be honest, I really don't want to bore you guys with the list of theories, but here is the interesting catch. The era of parametricism began in the early 1990s, where we witnessed some of the amazing projects, such as Vitra Fire Station by late Zaha Hadid, which is now being headed by Patrick Schumacher in London, and the invention of Grasshopper as a designing tool came in the year 2007. Now we have already passed the era of parametrics, and we are currently in the period of artificial intelligence. Well, we did have a couple of major developments, but not much has been explored in this phase. And one of the major breakthroughs in architecture of intelligence is the application of neural networks in designing. So if I have to design what neural networks is, it is basically a series of algorithms that aims to draw complex relationships from the data while comparing it to the human understanding, the human brain, which is why it is also called as an artificial brain. And the role and of generative design philosophies in neural network came in the year 2015, which is like hardly a few years ago. So, well, the neural network is quite complex and a strong subject in itself. Detailing it out would be probably a matter of a separate webinar. So, for now, let's just get in a state of mind that the neural network is basically the part or subset of artificial intelligence. So, to simplify it, neural network is a pattern recognizing algorithm which you use to unlock your phone or smartphones using a face ID or object detection. Okay, so I think my voice is a bit low. Just a second. Okay, so without deviating from the main theme, I would like to pull in the first slide again and break down the topic into a couple of important keywords. And let's get straight to the point where we can address the elephant in the room, that is AI, machine learning, and architecture. Again, guys, I would like to ask you to put down your names and mail ID in case you haven't. For the people who are joining in, asking everyone to check the link on Google Chat, where we have shared a link for the WhatsApp group where we will be sharing a lot of resources with you guys. And make sure you do the same on your Google Chat as well. Yeah. Okay. So since we are on the topic of artificial intelligence and machine learning, architects are not sure what to think about artificial intelligence. You're probably very familiar with how AI will change industries like cybersecurity, medicine, and manufacturing. But how about architecture? Which is why it brings us to three important questions: what, why, and where of architecture of intelligence. So, AI is basically intelligence displayed by machines and software. Today, AI is all around us. If you own a smartphone, tablet, or even a car, it is likely that it runs on some form of an AI, be it Siri, Cortana, or Google Maps, which we use daily. The ever growing connection of people via technology is enabling us more open and transparent look into every person's life. Now, let's understand why is it important in architecture? Why is AI and machine learning important in architecture? By knowing what we like, what we post online, what we buy, and where we go. Our smartphone, tablets, and computers, through complex algorithm, they know us empathically better than we do ourselves. And this is true. The data is constantly being uploaded onto the cloud. The information gained can be analyzed by an AI to even generate plans. This plan can then be improved later upon by architects and designers or planners, and the result would then you'll have like completely finished designs. To give you an easier example, let's look at the Tesla cars. They all have AI pilots in their car, and with every journey, car uploads the data onto a cloud server. This data is mainly about road congestions, road openings, the commute time, something very similar to the Google Maps, so that the next car that comes on the street now has updated information on what routes to choose. I mean, isn't that amazing? And the way we architects can actually benefit from it is by analyzing every data set. You might come up with a very simple solution of a roadblock. For example, just by increasing the road width by 1 meter could solve an urban problem, whereas you would think that, oh my God, I need to build a new flyover. So this is where artificial intelligence is going to help architects and in decision making. And their application is quite vast as well. By knowing everything about us, our hobbies, likes, dislikes, activities, our friends, and our yearly income, in fact, AI software can actually calculate uh, population growth, it can prioritize projects, it can even categorize streets according to its usage and so on. And thus, it can predict a virtual future and automatically draft urban.
Sir, you got muted.
Actually, you're not audible right now.
Can you hear me now?
Yeah,
Yes.
yeah, yeah. We can hear you now.
Yes.
Okay, thanks for that. Any idea where did you lose me? Was it just now, or I can
Yeah,
continue,
it
or
was
should
just
I should I
like
reloop?
Yeah.
2 minutes
Just a couple
before.
of seconds ago.
Yeah, yeah, yeah.
Okay, okay. So I guess you guys are done through this particular slide. So let me take it forward. Well, to be honest, it all looks fancy, but how do we do it right? How do we get into a right mindset of using such principles and ideas in architecture and design? What are the ways we can truly understand computer cognition? And by cognition, I actually mean intelligence. Well, there are a few questions you might think upon, and as I said initially as well, the aim of this webinar, or let's say this talk, is to let you guys explore the unexplored potential of artificial intelligence in architecture. Having said that, let's jump onto the interesting part, which is the process. Now, let's assume we have an architecture or a design problem. Okay. In the initial step, we would include learning from theories and building up understanding of the design problem. Let's assume that we have to design a housing complex. You would then start analyzing and researching about different type of housings, what are the definition of housing, and you would gather up a collaborative understanding of it. In the next step, you would start drawing inferences from the site at micro and macro levels. I'm sure if you're in a college or if you're in your second or third year, I'm sure you guys are already doing these steps. That is, at the site and the city level, you understand the project. Here, we will bring up understanding of, let's say, road networks, connectivity to the housing complex, potential entry exit points, and what are its actual impacts on the society. And upon gathering all the necessary information about the design problem, the next crucial step is to create an algorithm that can actually understand all these parameters. In simple terms, we would state the list of arguments which would derive the design, and let's call them as design parameters. Now, here is the interesting bit. Based on your list of design parameters, there are infinite number of design possibilities on how we can orient the building, where we should even propose the doors and windows openings, or what should be an ideal internal and external circulation. Doing it all by a human mind, it will probably take months or so in order to determine the right design option. What computer intelligence, or let's say artificial intelligence, would do is it takes all the listed parameters that we had just shown you in the previous slide, it'll understand them and it will compute to give you one in the million design possibilities. So instead of brainstorming over millions of options, which usually takes up a huge amount of time, we would now have a computationally driven solutions. Let's assume like 5 to 6 options we would come up with, which will satisfy all the listed parameters. And as a designer, your role is just to choose the right one, and then you are free to build aesthetics out of it. Now, this process is basically called as form finding, where you determine the form of the building using computational design tools, or let's say computationally driven methods. Now, you may think that if computer is doing the job, what is the role of architects, right? I mean, what is the role of designers? Uh, well, ideally, if you have to record the number of possibilities of different design iteration, here is a screen recording of a very basic AI model, where the form is broken down into various small modules to find the best design solutions for the housing complex. My question is, how much time would you take to do it if you're doing it like all by yourself? In this case, it took just 56 minutes. So to answer the questions, I don't think AI would ever take up our jobs. Rather, it would act as a catalyst in finding the right solutions for the design. Well, honestly speaking, a computer is a dumb machine. What it is good at is its computing skills, which we humans we lack. I mean, there's no harm accepting that. It is important as designer and architects to identify the right balance between the two. An AI would just give us the form. It is in the role of designers to sculpt the emotion out of it. At max, computer is going to give you just 5 to 6 best design possibilities, but it is in hands of designers and architects to basically shape the final vision. So here is an example of the selected form that we have from an AI generated algorithm, right? So, and the same can actually be translated into different design languages as well, be it the housing complex done by Moshe Shabde or the community housing done by Briak Angels. The final product would always be backed up by a strong research done by a computer intelligence or an AI. Over here, there's another example of a computationally driven flow plan. The aim is to increase the productivity of the office layout. This was done typically for an office building. It is done by enhancing the spatial and visual connectivity by manipulating the internal wall partitions and the furniture layout. The AI actually calculates the desired number of meeting rooms. It is actually calculating the area required per seat and even the total capacity on the floor. Okay, guys, before moving forward, I would again ask you guys just a polite reminder if you have just joined now, or probably you've joined during in the middle of the presentation, and if you haven't shared your mail IDs with us, with the team, please do that on the chat box. We are keen on sharing some of the resources with you guys. Uh, we are trying to build up a community over here. We have also a WhatsApp group link, which you might find on the chat as well. Just click, you will automatically be directed to the WhatsApp chat, and we can. I mean, this conversation is just not about just for 2 hours. We can take this even forward. So let's try and do that.
Excuse
Okay.
me, the link for the WhatsApp group is not available over there. Can you please share it?
Okay. Yeah. So I'll probably quickly ask one of my team members to share
Yeah, sure. Thank you.
the link. I think it's there, right? Yeah. Okay. Perfect. So now let's have a look at another form finding example, this time a bit interesting one. The mixed use project that I've just shown you guys aims in developing the form based on the computational measures. Okay. So the final form would look something like this, and I will highlight the reasoning behind it. Here, we're just keeping a note of the access route and also understanding the site has direct access to the water feature. In the very first process of optimization, the goal of an AI algorithm is to identify the right location for the building, where exactly I'm going to place my building, right? So that all towers can have the maximum views or the vistas of the scenery. In the second stage of optimization, the AI calculates the right orientation of the building to improve the visual connectivity. Thirdly, the form is then studied for sun movement and solar radiation. The parameters over here is to reduce the solar gain and increase the daylight factor. The factor of mutual shading is also considered here in order to construct or sculpt the final form of the towers over here. Lastly, the built form are then analyzed and tested for the wind intake. The atriums and the openings are strategically placed and oriented to make the most of the wind movement. The same exercise is done basically for all the three towers. And upon optimizing all the above parameters, the final build form would look something like this. That's the animation that is going on your screen. The computation driven form is thus the right amalgamation of human and computer intelligence. Okay, so having said that, I would like to show you an example of a real-time design solution that has been executed on the site. The project I'm going to show you now is Al Seef in Dubai. It is basically a mixed use stretch of about 1.8 kilometers upon having residences, retails, and commercial spaces. And the design is basically inspired from the traditional souk building in this region of in Dubai and UAE, which are having wing towers and the niche courtyard spaces. Since the site is located next to the waterfront, one of the main criteria while designing the stretch was to enhance the public movement and the visual connectivity to appreciate the spaces and even the waterfront promenade. So, upon having the general master plan, it was important for us to monitor the building height so as to build the character without being a hindrance to the views. We then created a machine learning algorithm to find the right balance of both and to achieve the best building skyline. Here's the video highlighting the numerous design possibilities after generating the right massing models. And I would like to show you the final results, which are some of the professional shots of the building, the promenade, and the quality of build form. The traditional architectural style, and the each house of the project has been designed to have a story of its own. Some buildings are designed to look as if they were built in 1960s with darker wall and less lighting and the simple decorative elements, while others have much lighter walls and they are more with the more intricate details. So again, an AI would just give you a basic massing, a basic form, but as I said before, it is in hands of designers and architects to actually bring out the aesthetics in whatever computational processes has been done. Moving forward, I would briefly like to talk about my research project, Neural Network Public Places, which has also been exhibited at the Pompidou Center last year, Feb to May. The research aims at defining the experiences and the design of the public spaces in the age of artificial intelligence. So, the soul of this research project is based on big data. Big data is considered as the biggest byproduct of 21st century. Almost everything we do produces data, from swiping our cards to liking photos on Facebook or Instagram, requesting maps from requesting Google Maps. It's all data. And big data today is actually acting as bread and butter of AI, which is basically algorithms and computational thinking. The term is even dominating in the field of design because it reveals humans' pattern. Uh, when data, in fact, the data sets, when they are read and analyzed in bulk, it reveals human sociology. For example, the data set gathered from Google Maps would reveal how humans interact with spaces, the connectivity, and the routes that we like choosing. These data would then help in designing better urban spaces. GPS system and location-based services give access to an important amount of data that is currently being used mostly for traffic analysis. But if this data set is being exposed to architects and designers and urban planners, it could open up to an infinite number of possibilities for planning. We can have more efficient and well-designed cities. The research project even took a broader perspective of the city to analyze at macro level and upon overlapping important urban fabrics such as building height, residential layer, and commercial layer, and the green spaces, density map of the city buildings, and most importantly, the choice map. The choice map reveals the deeper finding of the city. Now, what exactly it means is, choice map is basically an AI algorithm that calculates the probability of you selecting a specific route. For example, we all know that all the roads are interconnected to each other. Some are acting as primary road networks and some are secondary and tertiary road networks. Now, given a chance that you can go anywhere without any direction, the choice map would highlight the important road connections. No matter which direction you take, you would end up taking those important road networks. So basically, this is a map of London that you see on your screen, and all the road networks that are highlighted in red color, they have high chances of, let's say, interconnectivity. So for example, if you're walking somewhere over here, there are high chances that you would end up in the red zone. With this, we can actually understand the spatial connection and how the cities are, or let's say the road networks are performing in that ways. Now, after establishing the importance of road network, the next best thing is to measure the quality of an environment. Now, the quality of environment can be judged by mapping what you like to see and what you avoid seeing. It's very straightforward. But using AI algorithm, we can actually map how much area can be seen from a specific point. This again will infer a lot about other spaces, the characteristics of uh, places, promenades, gullies, or even sikas. Uh, Guys, I think some of you have your microphones on. I would request you to turn off for a while. I think it's causing this bit of disturbance for others. So just turn it off. Don't turn me off. Okay. Now, mapping it on a city level, the research explores the visual preferences to measure and judge the quality of spaces. On your right, what you see is basically a graph representing the visual areas for those specific routes that you see at the animation on your left hand side of the screen. Now that we have already determined the importance of road network, the next important step is to actually map the human movement. So let's say you have to move from point A to point B. There are possibly 100 ways that you can choose your route, and all of them would have different characteristics, be it visual characteristics as well. So which one is the best? So the research aims to build a comparison between the human navigation and the navigation chosen by an AI model. It is inferred that there are a lot of unforeseen factors that determine human movement. You may find a chart wala or a coffee shop on your way, and you might take a detour to reach to your destination. Which is why here is a prototype of an AI model that we created for that replicates human navigation. So over here, the AI agent, it navigates by learning, it finds the mistake, and then it resolves it to reach the goal or the destination. So the final results lead to the shortest route towards the destination with the best visual environment. And here is the comparison between the two navigation model, the navigation by, let's say, the human navigation and the navigation by an AI agent. I then calculated the urban fabric with respect to human movement. The easier way to do it is to actually divide the city into smaller cells or grids. I then calculated the number of people stepping into a particular grid. How much time duration do they spend in that particular grid? And what is the dominant direction these guys are taking forward to moving from one place to another? Over comparing all these three data sets, what we can see, one of the major inferences is what usually seems obvious is actually never the obvious. Some of the secondary and tertiary road networks, which we think are not really important, are actually one of the most crucial and important road networks in the city, and are probably the best routes to commute as well. Now, upon interacting with the city by movement, I think we are living in the world of social media, and social media is also an essential parameter these days to quantify the space. For example, there are places in the city that you would like to go and click pictures, right? Like be it downtown in Dubai, or be it Chandni Chowk in Delhi, or Trafalgar Square in London, or even Times Square. Or let's say some of the key attractions as well, such as Taj Mahal, or Qutub Minar, or Humayun's Tomb, or Burj Khalifa. The reason we interact with these spots is because these places have unique spatial characteristics and how they respond to the urban scenario as well. Now, there are tools we can actually map the social media impressions, and it would tell us the exact location from where these pictures were taken. So, for example, if I have to understand which are the areas in the city that are functioning well, I would simply create a density map or a heat map where the most number of pictures are being clicked, and I will probably realize that okay, these are the places from which are probably most active in the city for, let's say, a public attraction, or it's probably one of the best tourist spots that I have in the city. And if we collect over 10,000 pictures and map their geolocation, the city would start revealing interesting characteristics, which I believe is it cannot be perceived by human brain. In the video, you may see the red nodes. These are the points from where the pictures are being taken and uploaded on the social media. In fact, with their specific hashtags as well. So it is even possible to monitor the emotion behind these pictures just by analyzing and reading through their hashtags, or let's say the keywords. The density of these nodes highlight the favorable areas of the city. Architecturally speaking, if you want to build a shopping mall or a tea stall, let's say, or any consumer-based model, now as a designer, we are capable enough to identify the right location for better businesses and interaction within the city and for the city inhabitants. So here is an overlook of a computational brain, or let's say an artificial brain I created to understand the city fabric based on the parameters we just discussed before in a few slides. The aim of the brain is to identify a pattern within these parameters and to establish a design language. The parameters are being computed that are human movement, there are social media impressions, there are building volumes, and they are in fact the colors from the social media impressions. Over here, research highlights a particular area of the city which needs to be redesigned. In the initial process, the human movement is identified, followed by their visual preferences. The artificial brain then suggests a desired form tailored to that particular site. The research over here celebrates the distributed and dynamic qualities of big data, in fact, which is utilized to generate the spatial layouts that are able to take advantage of local and global inputs, environmental concerns, and basically we can design based on the needs of the residents of that particular locality. So here is a cross section of the site with the built form that is basically suggested by an artificial brain. The form here has manipulated the buildings catering to the human needs and basically to their preferences. Another visual highlighting the AI visionary space, it suggests that the built form over here is the right prototype with a flawless human movement, and it is socially well connected. By socially well connected, I mean it's like social media wise, it is quite well connected. Uh, it is even possible to quantify that in terms of forms and build forms. So, in order to test the artificial brain I created, it was important to test this algorithm into other parts of the world as well. Up until now, the data collection and the city fabric were very specifically done for London. But to monitor the authenticity of this algorithm, I then tested the same on Paris, which specifically on the island of Notre Dame, which is also known as Ile de Citadelle. Well, after the Notre Dame fire, I thought it would be like some tribute to Notre Dame. Why not? So the build form that you see over here is not to be confused with the final design output. Consider them as general massing options. And again, it is in hands of designers to cultivate the aesthetics out of it. I was fortunate enough that my research project was selected and presented at Pompidou Center in Paris, along with some of the elite projects such as Morpheus by Zaha Hadid and Rafiq Anadol's Melting Memories. Moving forward, I would like to show you a small simulation which was carried out for an architectural college. Over the left hand side, this is basically one of the admin block for that particular architectural school. And on your left hand side, you may see a couple of spaces such as committee rooms, principal office, which are very formal in nature. And there are some of the informal spaces such as studios, thesis studios, and lecture rooms on your right. Now, upon running the simulation of spatial connectivity, you may see the corridor is acting as the spine of the building. The areas marked red and orange are the spaces with the maximum spatial and visual connection. And the areas color coded with the blue and dark blue are basically in isolation. That is, these spaces are not very well connected. You may also notice the pockets of deep red nodes. These are basically the intersection zones with highest spatial connectivity, and as they are either intersected by the door opening or any other perpendicular corridor. Now, you may notice the difference in these two particular zones, the lecture room and the computer lab. I mean, clearly the AI model suggests that the computer lab falls under the blue zone and is not spatially well connected, even though both the rooms are almost the same size. Now, analyzing plan now, you may identify the difference being the door opening. What if we propose another opening on the side of the lab? Would it affect the spatial and visual connectivity? So let's try that out. And upon running the AI simulation again with additional door this time, in the new spatial connectivity, both rooms are given equal importance. They are spatially more connected, and you would end up interacting with both spaces equally, in fact. Now let's add another dimension to it. Let's assume you have to go from a thesis studio to principal office. That is from point A to point B, whereas point A is being the starting point and point B being the destination. The AI simulation here is calculating the characteristics of your vision. What are the areas you see while going from point A to point B? Let's assume you have to detour a bit to catch up with your friend and then you head back. You may also note the change in the visual areas, which is over here, top right, uh, while you're moving from one point to another. This is how you can actually quantify the spaces. This is how you can quantify how much you can actually see, how much you can see, perceive the visual environment. Now, this analysis would be quite interesting in determining the opening and the wayfinding as well. So with this, I would like to give a brief introduction about the Grasshopper, or I mean, this entire simulation or whatever I've shown you guys up to until now is basically done on Grasshopper and a couple of other AI based softwares as well. I believe some of you guys are already aware of Grasshopper or Dynamo, where we use components in order to create a program. Well, Grasshopper is basically a visual coding language. So instead of you using a Java or C Sharp or C++ or anything in order to code it, we architects and designers, obviously we don't have that stronghold on coding languages, but then these are the tools which we are using these days, which is basically visual coding language, in order to create our own algorithms. So again, guys, if some of you have joined recently or probably in the middle of the presentation, I would like you to uh, join in the WhatsApp group using the link. Someone from the team will again share the WhatsApp link over the chat. It's going to be a quite interactive group. We will be sharing some of the resources after the presentation as well. I will be giving away a couple of scripts to you guys, the Grasshopper scripts for you guys to practice at your own end. In order to do that, make sure if you guys can share your names, the name with which you have registered for this webinar, and your mail address as well, so that we can create a broadcast mail for you guys. So as I was saying, this entire simulation and all the analysis were actually done on Grasshopper. Now, previously Grasshopper used to be a standalone application which you had to install in the older versions of Rhinoceros, which is Rhino 4, 5, and before. But in Rhino 6 onward, it is now already embedded into the software. So all you have to do is you just have to, I mean, you don't have to install it anymore. But if you guys are using older version of Rhino, you would have to install it separately. And if you already have it installed, and or if you're using Rhino 6, you can just launch your Grasshopper by just typing in Grasshopper on your command section. And soon you do that, it opens up a Grasshopper window, which would look something like this. That's the one that is highlighted over here is how the Grasshopper interface would look like. And over here, you can actually identify the version of your Grasshopper that you're using. Again, since we are dealing with Grasshopper over here, I would like you guys to probably quickly um, mention your level of understanding of, let's say, Grasshopper. Are you at advanced level? Are you at pro level? Are you at intermediate? Or this is the first time you're learning? Or hearing about Grasshopper, just mention that you're a beginner or something, so that it would help us and our team in order to understand what kind of mindset you guys are at the moment. So I think before I take it further, I would like to ask you guys quickly. Was the concept of artificial intelligence and machine learning, was it easier to understand what we can do, what we can't do, what are the capabilities of it? I mean, how comfortable do you think this is? You can unmute yourself,
Hi
and
Piyush, can you hear me?
yeah, I can hear you very well.
Hi,
May I know
Abhinav
your
here.
name,
I've
please?
actually been a fan of your work since your Athenium project, so congratulations for everything you've achieved since. I just
Hey,
wanted to
thanks.
ask a lot of the
Can I
data
can I
that
can I
you've been,
get your name, please? Sorry, I missed your
Abhinav,
name.
Abhinav, I've,
Abhinav.
yeah.
Thanks, Abhinav.
So I just wanted to ask, since you've been using Grasshopper and all the work that I'm seeing you present, it requires probably, just correct me if I'm wrong, it requires a lot of open source data. Where have you been sourcing that from? Because if I'm based in India, I probably do not have access to so much open source data, say in an ArcGIS format or something that I can use to input into Grasshopper. So
Okay.
could you just give me a suggestion for what a starting point for me would be to collect all this data to actually input into Grasshopper?
Okay. So a very good question, because I do get this specifically this question a lot of times, because some of the advanced countries or advanced like well-to-do places like London or any other European countries or in US, you have well-sourced data libraries which are not as comprehensive as you have it probably in India. But again, with the initiative of smart cities that are happening, the government organization are actually creating a lot of portals where you have a lot of open source data, which is dataset.gov.in. You can just type in, you can check, you can download some of the crucial information about the sensex, not the sensex, sorry, the population and the land use patterns and stuff. Uh, about the GIS, I would say you can use OpenStreetMaps. There are a lot of plugins in Grasshopper which you can potentially use in order to gather and probably fetch all the data. You can actually, so for example, I've been working with the data of social media, let's say. Now these kind of data are already available out there. It just, they are not readily available, or probably we don't know how to use them. But again, using Grasshopper and just bit a really beginner level of scripting, you can gather all the information. In case you don't have the data, I think the right way to do is to create your own data. So I mean, that's the only way forward. So I hope
Yep.
I am able to answer your
Yeah,
question.
yeah.
There are a couple of
Thanks.
open sources that are available on Indian website, the government websites. Do check that. Otherwise, there are for specifically for the city plannings and stuff, or let's say if you want to get the GIS data into your models, just try OpenStreetMap. It'll help you to gather all. You can straight away extract it into your Rhino or an AutoCAD or anything.
Yep.
Okay,
Thank you.
so my pleasure, totally my pleasure. Okay, so let me continue with the Grasshopper. As I mentioned, this is how the interface of Grasshopper would look like. And if I have to explain you in detail what all are the components, just in case this is the first time you're having a look at the Grasshopper, this is uh, the Windows title bar that we have. That's Grasshopper title bar, and then these are the main menus. The file browser control is basically where you save your file name with. It could be any file name, so whatever file name that you choose. And this particular situation, it was unnamed, so it is mentioned as unnamed. And this is one of the most interesting and crucial part of Grasshopper, which is the components palette and the canvas toolbar. And lastly, uh, the canvas, which is where I would say the magic happens. So you basically drag and drop the components from the components palette to your canvas, and you start building up your algorithm. I'll just give you all a quick session of how we can do that as well. Before doing that, I would like to show you how we can actually, I mean, there are some of the components that have the, like pull up a subcategory panel as well, where you can find in much like more components, detailed components, or you can just hover your mouse over any of the components in order to see the description of it or what that particular component actually does. Once you are well exposed to the interface of Grasshopper, you would probably memorize some of the key components. Let's say I want to do division. Now you can also double click and you can type in what component that you're looking forward to. Once you do that, it'll give you a certain list of suggestions, be it divide length, divide distance, or you want to divide curve. So based on your preferences, you can even choose just by double clicking and selecting the right component that you are willing to go forward with. Having said that, let's also understand how the components are structured. So basically, uh, any simple component would have three to, I don't know, somewhere around 10 different component tabs, or let's say the parts. This is a very typical component that we have, which is used to make a circle. So these are divided into 5 sections. Let's say the first one is basically the input tab, which is where you plug in all the information or the data into that particular component. Second being the input options. For example, this is for P is basically for the position, which basically means where exactly you want to position your circle. And once you're doing the circle, there are certain information that circle actually requires in order to be built or constructed, which is basically the radius. So all the data about the radius will probably go in for this particular input tab. Body is basically the part where you have the algorithm, or let's say the source code. Options and output tabs, output options and output tab is basically, after that it'll give you on your Rhino viewport, it'll give you a circle. Once you put in all the input tab, once you put in all the data, you can fetch out the output. And the way you add in the data is basically you create a slider or any number, and then you just have to hold the white bump and then you connect it to the radius or whatever position that you would like to have. And once you have the components gets active, and it will automatically construct a circle for you in this particular case. Now it is obvious that there are certain set of, or let's say the types of information that you can give at particular component. Let's say R basically stands for the radius, and it is very clear that it is radius would particularly mean a number or an integer value. So if I am willing to give a text input to a radius, it would obviously notify me an error, which is why the component then turns into red. It would probably say that the wrong data type. So you probably need to enter the numbers over there. So this is the basic understanding that you have to develop once you start working with the Grasshopper. And over here, I'm just trying to show you the basic object status of every component. What are the different statuses that any component can go through? This is the default status of any component, where you haven't given any information or any data to that particular component. Once you click the component, it turns green, and once the component is there with all the sufficient data that you have given in order to construct something, it turns white, and it turns red if you have given a wrong kind of data. For example, in the previous case, in the previous slide, we have given text to a radius parameter, which is obviously not compatible, and will turn red. These are the visual preferences for a particular component. It can go from white to gray to off-white, or let's say darker gray as well, where you can have the preview on and off for every component. And if you want to enable or disable a particular component, it can be done as well. I'm going to show you all that in just a couple of minutes. So let's straight away jump to Grasshopper. Whilst you're doing that, I would like to understand if you guys are, if you can just give me a heads up again on the WhatsApp group, how well do you know about Grasshopper? Are you at advanced level, beginners, or uh, is the first time are you, if you are exposed to Grasshopper? I just want to understand the mindset at the moment. So looking at the kind of bash that we have today, I will share the files with you guys. So, okay. So I see Abhinav, you're advanced. I'm sure you guys, you've been using Grasshopper and other softwares, I guess, uh, for a while. And I see it's the first time few people are looking at it, and basics and bit more. Okay, cool. Okay, whilst people are doing that, just mentioning about the beginner level and about the proficiency basically, if you have any questions quickly that we can address for like next couple of minutes, please do shoot the questions on or probably type in on the chat if you want, if you're comfortable, or just you can unmute and you can probably ask the question. I see there are a lot of beginner levels, so I'll try to tone the script down so that it is easier for you guys to understand.
Hello, sir. Hello.
Hey, hi.
Hi, this is Shoktik here. I am an architecture student. I want to ask you that in order to study about AI in architecture, is there any scope in India, or what kind of institute should I, or what kind of study should I approach to get into AI and architecture?
AI in architecture. Well, okay, currently, okay, I do know there are some of the universities who are introducing computational design into right from the bachelor's level as well. I think from year three or year four, some of the students these days that are actually exposed to parametric form finding and all these generative design learning tools as well. So some of the universities lately have been quite proactive with and keeping up with the current stats of, let's say, what is going in the world. If you're looking for some dedicated masters in the field of artificial intelligence architecture, unfortunately there aren't any
Yeah,
university in specifically in
yeah.
India who are teaching, or if there is a very dedicated course for that. There are courses elsewhere. I think in a year or two, I think we should come up with something like that. Definitely, I think we might as well. But otherwise, there are universities such as UCL, say Bartley School of Architecture. You have SciArc, you have IAC. There are universities in US as well uh, who are actually teaching and they are taking up the role of artificial intelligence in architecture. So there are some universities who have dedicated course, uh, but as much as I'm aware of in India, I think it is only, let's say, a substitute subject at the moment. If you're interested, you can go for you can avail for it. But I think there are a lot of workshops that are happening these days. So if you're interested, I would recommend you to probably join a couple of them, see how you stand, how you understand all these things, and I think you'll be good enough. You'll be good enough.
Okay, thank you.
Yeah, Piyush, do
Hi
you have
Piyush,
any
this
idea
is
of any of?
Avigyan.
Sorry. Before the next question, I would ask every one of you to probably shoot down your questions on the YouTube as well, if that's possible. I mean, or in the chat box. I mean, okay, I think there are guys who are typing the questions on YouTube. Can you do that on the Google chat box? I think it's a lot easier there. Okay, sorry, someone was asking the question. Sorry to cut you.
Hi Piyush, this is Avigyan. Am I audible?
Yeah, yeah, loud and clear.
Yeah, okay. Piyush, I just saw in one of your slides in your design research, you had mentioned about AI computing the environmental quality. So, can you throw some light on that? What exactly were the parameters that you had used for calculating the environmental quality of a particular place or something?
Okay, so my whole research was actually to quantify the unquantifiable aspect of the design environment, right? So the reason I spoke about social media is basically we perceive environment in three-dimensional spaces. We see and then we have our favorites and then probably the spaces that we like to go through and not. Are you talking about that particular slide?
Yes, not just the social media, but I remember in one of the slides you had talked about how people are going through places from where the environmental quality is being judged upon it.
Okay. I
Yeah.
think you're talking about this particular one.
Yes, this one, and there was another one where you had mentioned about that. I don't exactly remember. I mean, I don't see the slide that was in
Okay.
front of me at that point of time,
So there are
but
basically two slides where we are actually trying to comprehend or let's say quantify the quality of spaces. Okay.
yes,
So
absolutely. This one
number
was
one,
one of them.
yeah. So number one over here, we're trying to calculate how much area can be seen from one particular point. For example, let me just run through this slide again. Let's say this is a particular route in the city. Okay, if I'm moving from one point to another, what are the visual areas that I'm exposed to, or how much area am I actually able to see? Which is why I've added a graph as well. So the four routes that you see over here are basically the four routes over here with their own different visual characteristics, and all of them are giving me a different understanding of visual excitement. For example, let's say for this particular route, I'm walking. This is basically Thames over here. This entire simulation has been done on London. So let's say I'm taking this particular route. I'm walking. I see a bit of open spaces. Once I see the open spaces, obviously the visual area increases. The isovist area basically means the visual area, and the maximum it is reaching up to 80,000 square meters, and minimum being somewhere close to 67,000 square meters of visual area that I'm exposed to. So let's say I'm walking from this point to this point, I can definitely see that okay, I don't see much of the spaces. The visual quality over here is a bit low, as I'm not well exposed to, let's say, light, or not maybe the buildings are quite close to each other. The spatial context, or let's say the density map or the density fabric of the buildings is a bit high. But as I move towards the water body, let's say, I am more open to the spaces. The space gets wider, it is open, and then I reach to a point where I can actually see, let's say, the river, or Thames over here. So this is one of the cases where we are trying to quantify uh, vision, how much you can see, and based on that, we can draw some inferences if the road network is a bit small, or is it like how is the wayfinding happening over there? How easy is the navigation? Am I able to see this point, or let's say the couple of key interactions? Is it possible to do that or not? And the other place where we're trying to comprehend, let's say, the quality of spaces is basically mapping down the impressions. Basically, if you're walking from one point to another point, okay, so what I've done over here is I've divided the entire city into grids. Okay, so, and every grid, or let's say every point has been tested for three things: basically number of impressions, mean time, and dominant direction. Now what I actually mean by this is, let's say this is one grid, and these are the number of impression, that is these many times people have actually stepped in that particular spot. This is basically it is giving me the information about in that particular cell of, or let's say in this particular point, how much time people are spending in that particular cell, in that particular grid, which would then help me to understand the importance of that particular uh, grid. And lastly, from this particular grid, in which direction are they moving? Are they moving this particular direction, or are they walking north, south, east, or west? It depends. I mean, if this is a highly active grid, are they taking this particular direction, north direction, or are they taking a southern direction? So this, when I had all these three datas together, it then reveals some of the patterns. So basically, the red ones that you see are basically you have the maximum number of impressions over here, whereas the other part of the city, or let's say as an architect, or probably as a person who's been staying there, we can say that okay, this is a residential area, so obviously you won't have that many impressions. But again, you may understand the dominant direction. You can compare how much time people are probably spending in that particular grid, which would then help you to come up with some really interesting observation and inferences about the quality of spaces that it might have. Which is why I took it a step further, and we started taking the pictures in order to see that how is actually the space is functioning. I hope that answers your question. So basically, the parameters where the building heights, the parameters are uh, the land use plans. They are basically figure grounds and everything. So that's the key parameters over there.
Hi, Piyush.
Hi.
Thank you so much, Piyush.
Hi, Piyush. Anuj here. Uh, hello.
Okay.
Hello.
Guys, I think we still have a couple of more questions, so let's take it towards the end. I would actually like to show you guys really, like, since some of you guys are fairly new to Grasshopper, I would like to give you a brief working, and I would like to show how exactly we can work, how easy it is actually to work in Grasshopper as well. So let me just open a really small exercise that we are trying to do over here. Uh, we are going to construct, or let's say quickly do an interface on, or let's say we'll make an algorithm of what we see over here. Basically, if you're moving from one point to another point, what are the areas that you see, how you actually are, how are you able to comprehend the spaces? I think we will quickly do that on Grasshopper. I would like to share the script with you guys towards the end of the presentation, so make sure you have shared your mail IDs with the team over the chat box. We'll create the group and we'll definitely send it through. So let's say, okay, so brep is basically like you can, okay, as I mentioned before, you can double click and you can add in any component that you know of. Let's say you want to add a box, you can do that. If you want to add geometry, you can definitely do that. But again, for someone who's fairly new to it, it will take you guys a couple of times in order to understand the whole interface. But once you get hold of it, I think it's pretty straightforward and it is very easy. So let's say I have building geometry over here. I can have brep and I can building. So that's my building, and that's the road network that I have. And I would like to quantify the visual environment once I'm walking from this particular road and how much area I'm actually able to see. Okay, so that's the whole intention of it. So instead of uh, us moving from this point to this point within the building, this time we are doing it at an urban level, let's say, so where we have some clusters of building and then we are moving from one point to another point. For guys who are sharing their IDs on YouTube, I would say or probably request you to share it on the Google chat. I think the chat box would be much efficient. Okay. Okay. So once I have that, I would briefly display the geometries, how it is going to look like to me. So I can, as I mentioned before, it's very straightforward. I just have to click the white bulb over here, and then I can link to any of the components or whatever I want to do. So this is the part where I am trying to display geometry in particular fashion. Okay, so let's say I want to display my buildings in a particular color or something, where I can turn off the preview of this building. I can turn the preview of the road that I have, so that I'm able to see the visual characteristics that I have. Let's say I want to change this color from red to any other color. You can very well do that. You can change the color of your. This is just a visual representation of it. Nothing that that you'll be worried about, to be honest. But then let's get on to the interesting part where we actually create the algorithm in order to create the visual or probably test the visual quantification of it. So we need to have something where we can actually move from one point to another point. And there is a component called evaluate curve, where if we put in or if we plug the road network to that particular component. Okay, so again, it is giving me an error. The reason being, it, it turns yellow or turns orange, which means there is some error. It doesn't turn red. It turned to yellow orange, which means there are some of the parameters that are missing. So the input parameter failed to collect data, and which is why I have to connect the parameters down. And once I have that, I can see uh, some of. Okay, so that's the point that we can have. And the way this section is basically we are setting up the geometry and we can move from one uh, point to another point of the road network, which is where we actually want to calculate the visual characteristics as well. Okay, moving forward. Once we know where exactly we want to calculate the visual characteristics, let's say I want to calculate it somewhere over here. I then use a key component, which is basically a view rows component. It is one of the default components that comes in that is there in the Grasshopper, which is also called isovist. So there are different type of isovist that you can potentially use. So the one that I'm using over here is view rows. So what it is asking me for is the context, plane, and the radius. So context is is the portion where all the geometries, or let's say all the visual obstructions, the geometry will go in. So I would plug my buildings into the context part. And plane is basically from the point I actually want to test my visual, test the view rows. I put that in. But again, it is not giving me any answers at the moment because my viewing radius is very low. So, or probably it's not there at the moment, it's empty. So I would have to give a viewing radius, and still you're not able to see anything because the preview of this one is off. So let me turn the preview on, and you can see that, okay, if I'm standing at this particular point and if I have to move from one point to another, I have a better visibility over here because obviously there are no visual obstruction. But as I move forward, so here you can actually create some really interesting analysis about your spatial geometries, how a building formed. Basically, you can do a lot of urban and uh, building analysis as well, where you try and understand the figure ground basically. Now let's try and represent this in a probably much interesting way. So I'll turn the preview off and let me show you what these basically mean.
Yeah, Piyush, I think someone's muted you again.
Yeah, am I audible? I think it should be
Yeah,
fine.
you're good.
Thanks, Abhinav, right?
Yep.
Yeah, thanks. Okay, so if I use a simple component of view rows, and if I just check the README component, I can use a panel tab. Panel tab is something that you can find in the default Rhino settings as well, in the Grasshopper settings as well. You can just have to click the yellow one and you click and you can simply drag and they'll give you all the information that you require. Or you can double click and you can type panel and you'll get the same box again. So it is over here, it is giving me the information about the blocked angles. And over here, it is giving me view rows, which is basically all the area where I can actually see. So let's try and visualize it. I will add it to the building surface. And let's say I would like to change the color of this geometry to something else, which is, so over here, I'm just turning it to yellow for like visual purposes. That's it. And if you want to understand what are the visible angles, you can again like how much visible angle is there. You can definitely do that by again adding in a panels tab. Or if you want to understand how much blocked angles are, probably these are the shapes that are being blocked. So uh, let's say it's a planar curve. So let me plug in the blocked angles to the boundary surfaces, and I would quickly visualize it based on a particular legend that a gradient that I've created, which means uh, okay. So I have basically what I've done over here is I have color coded all the blocked angles based on how much are they blocked. Is it big amount? Is it a small amount? I've just color coded that, and the yellow is the one where you are actually able to see everything. So it is fairly a very simple and straightforward algorithm where we are calculating the view rows. And if you want to again move from one point to another, it is straightforward. You can actually calculate, and once you do that, it keeps on changing, and you can calculate. You can have the areas as well. Let's say you want to understand how much area is there for that particular one, that particular yellow hatch that we have. So just double click and type in the area component. You'll get a component over here. Connect this, and maybe so it is giving me this much amount of area at this particular point. Let me turn the preview off for this one, and this would change with every movement. Let's say I go somewhere over here, the values change. So these are the areas that we can do. Okay, so that's a very simple and straightforward working exercise of Grasshopper. It is usually not very complex. So once you get hold of it, once or probably let's say once you are exposed to the Grasshopper interface. Working on this is fairly very easy. For the guys, okay, let me minimize again. Let me open the presentation again. Okay, we were here. So for the guys who are actually interested in this interface of artificial intelligence and computer intelligence, I would definitely recommend you guys to have a look at uh, what our team is doing at the moment with like at Equim. We are taking a couple of workshops. We have had close to 6 to 7 workshops the past year. Uh, this is AI Urbanized, which is meant for an intermediate or advanced level students. I would say intermediate would be a good position to start with. The reason being, we are going to have this particular workshop from 3 weeks from now. Uh, the registration starts today. So today we actually have the early bird registration where you can actually avail the discounts of I don't know, close to 3,000 rupees INR. The base price is basically 8,999 plus taxes. But if you're enrolling today, uh, which I would recommend if you guys are interested in understanding the urban fabric of the cities and how we can deal with spaces at an urban level, do check out the link. We will share the link with you guys over the WhatsApp and over the chat box as well. Go through the course structure, how we are going to take it forward. But again, this is meant for uh, students who are at intermediate level, bare minimum. If you're fairly new to this entire world of artificial intelligence, or let's say Grasshopper, please do check the parameterized version for it, which is there for at the beginners level. These are some of the works of the students that they have done during the workshop. I think the output is again pretty great, I would say, starting from scratch to building up something like these forms if you're interested. And there's a reasoning behind it. It's just not going to be all form finding exercises. There's going to be some logic about it as well. And once you feel that you're proficient about with this particular interface and you're willing to learn and expand your horizons even much further, I would recommend you guys, or let's say if you're already exposed to uh, parametric world, or let's say Grasshopper you've been using it and you want to learn more about at an urban level of it, I would ask you guys to look into AI Urbanized. Yeah. So with this, I would probably just open up for question and answers. I think some of you guys have already mentioned stated that in the chat. Okay. So I have a question with me. Okay, so the very first question is, can you give me the list of softwares or plugins you have used to demonstrate the connectivity of spaces and other things you had shown? Okay, I'm sorry, I don't have the name of the person who has asked me this question. But to answer your question, this entire thing or the simulation of connectivity, as I've shown you, it is done on it. Okay, there are actually a couple of softwares, or let's say the applications in the market where you can do it. Number one being Space Syntax, which was developed at UCL Space Syntax Laboratories. And the one that are widely used and are very quite efficient is again in Grasshopper. There are default components. You don't have to install any plugins just to understand the connectivity of it. But in case you want to take it a level up, there are a couple of plugins like decoding spaces, and the second one being Ladybug and Honeybee, where you can actually create interesting diagram and inferences of visual connectivity over here. Again, it's all done on Rhino. Uh, if you're if Rhino is something that you're not exposed to, you can do that again in Dynamo as well, which is in Revit. Or if you're exposed to some of the gaming interfaces such as Unity, it is possible to do that as well. But again, over there, it's a bit of a complex I would say it's a complex interface. Probably in Unity, you would have to start from scratch in order to do it. Script it from C sharp. Okay. The second question being, is there any tutorial or webinar on this? How it can be done by using Rhino and Grasshopper? I think this was probably in relation to the connectivity of spaces again. I've just given a small demonstration of it and how we can understand the connectivity of spaces and everything. Uh, if you're willing to learn more about this, we have this in our workshop module as well. So if you're interested, do check out the link. It is there. We will share on the chat and probably on the groups as well. But then if you are willing to do it on your own, there are a couple of tutorials available online which you can have a look at, and we can watch. The thing that we usually call this is basically view rows diagrams. So if you just type that in, I think you might find a lot of information on that. Okay. Okay, this is slightly different from the topic, but there's a question: if I get into UCL for post grad in architectural computation, after that, will I be able to continue my professional profession in UK or get a licensure there? The answer to that question, I'll keep this very short because this is out of the topic. But yes, you can do that. Yes to both the questions. Uh, I think with the new visa regulations, you are allowed to stay there for 2 years. So it is very easy for anyone who are going to study from this, let's say last year onwards. If you're studying there, you still have 2 years of your visa where you can actually collaborate and you can work with a lot of firms which are based in UK. And once you're there, I think if they like you and if you're good with your stuff, I think any company would like to take you in. So you can, once you stay there for like 5 years, you can apply for citizenships and like blah blah blah. There are a lot of things into over there, so you can Google that at your own. So, but to answer your question, yes, you can do that. How you generated that traffic mapping, and are there any plugins there? Okay, so this one was a bit tricky and complex one. The traffic mapping was basically the GPS thing that I've shown you guys. So it has been done by using a couple of different softwares. It was done on Unity. Unity is basically, if you guys know about Unreal Engine, it's more like that. So it's done on Unity, it's done on Grasshopper, it's done on QGIS. So it's basically three different softwares. There's a proper balance, or let's say there's an amalgamation of data traveling from one point to another point, another one software to another software to another software, which is why I think the computational design tools are very efficient in order to do that. Had it been something that you have to do it very logically and by using human cognition, I don't think you have that liberty to do that, which is why uh, I would say computational tools are winning these days because the compatibility is very easy in any of these softwares, and I can have the data, I can have the form constructed in Grasshopper, can be moved to Revit, I can jump that same model to Unity or Houdini on Unreal Engine or anywhere I want. Okay, so next question. Okay, as we are talking about AI in which we are using Grasshopper in PIM, we had the same thing called generative design. Is similar or different from each other? Okay, generative design. Okay. Okay. If you're talking about machine learning or generative design tools, there are different levels of it. There are subconscious learning and there are conscious learning. Conscious learning is the case where you decide the parameters on your own. For example, I'm making a view rows diagram. Just I'll give you a simple example of a person traveling from point A to point B. I set the parameters that, okay, I want the maximum visibility. So that's the parameter. And while using the generative design tools, I'm going to identify which are the best locations where I can, at which particular point I can have the maximum views. So that is conscious learning where I am stating all the parameters that, yes, I want maximum visibility. But now in a situation where you are doing a unconscious learning is basically that paradigm of generative learning where you don't state any parameters. Okay, you give computer you, or let's say you give an algorithm the set of the amount of data set, and once you have the data set, the computer basically learns from that. It starts building up the relationship between those data sets, and then it will start giving you its own results, which are basically you won't be able to comprehend it with like a normal human brain. Because let's say if I have to give you an example of I did show you guys the working of an AI brain, right? So let's say this particular slide. So okay, okay, let's start again. So these are the data sets, these are the data set layers that we can have, and the computer usually brings up these let's say relationship between the data sets that cannot be comprehended by human brain. For example, if you would ask me to build up a relationship between a building height and uh, RGB values of any particular space. I can't do that. I mean, it's something that it cannot even perceive that. But computer can analyze the whole interface in numbers and it can bring up the relationship, which is again a different paradigm of generative learning. So yeah, it's AI is all the same. It's just there are like different levels of it. Okay. The next question. Okay, Anuradha TK on YouTube, you have asked how we start these kinds of design. Well, there's no good and bad time to start. You can start from today onwards. You can start right away. Probably after the presentation, we are going to share this particular script with you. I'll probably share a couple of more with you guys. Just try exploring the interface first. Let's just try how we can actually. I mean, start with a simple cube, right? Just the way I'm sure you guys must be aware of how we can build a model on SketchUp. So for the same things that you're able to do on SketchUp, try doing it on Rhino or Revit or using these parametric tools, right? So once you do that, I think uh, slowly and steadily, like step by step, I think you can easily get to a point where you are well versed with these kind of technologies. I think there's you can easily start that. Don't worry. It's the first step is always the hardest one. So once you are into the interface, you'll start liking it. You'll start looking into a couple of tutorials on YouTube, the beginner level tutorials for YouTube. If you're not really comfortable with the YouTube tutorials, you can look into a lot of workshops as well. So just dedicate your time. If you're really passionate about it, I think just give it a head start. Okay, next question.
Piyush, would you mind
Yeah,
if I go ahead and ask one?
yeah, please.
I'm sorry, it's 3 a.m. here in Seattle, so I'm just trying to stay up. So I'd like to
Oh,
ask.
wow. Yeah, sure.
So the question I have to ask is, could you help us with some kind of a blueprint of what kind of courses you took in UCL to build up your skill set? Since a lot of us coming from India, we do not have the sort of mathematical base, at least in our 5 year undergraduate education, to understand the concepts of machine learning and artificial intelligence as well. A lot of us are not very well trained in, say, parametric software. So even if you explain somebody what visual coding does, it becomes very difficult since it doesn't come naturally to us in our aptitude. I don't know if you faced the same challenges when you went to UCL, but could you give us a blueprint of, say, how you went about learning at each single step and then built your proficiencies with first Grasshopper, the other softwares, say probably learning any kind of coding and then visualizing and explaining all your thought processes as amazingly as you've done?
Okay. Uh, okay. To be honest, for the first time, it was quite overwhelming for me as well. I mean, I was blown away with the interface. I was blown away with the coding part of it. I was to be honest, I was a bit scared because I've always been really passionate about the computational design and how the technology could actually make a huge difference in architecture. But in order to do that, I think it was really tough. I mean, I think it is for the first timers. I think it is always really tough. So, but having said that, I like reading. I like reading a lot. So I've been reading a lot of things and how to do these things otherwise. So what I'm going to do is I am going to share a couple of screenshots of the books that I would recommend you guys. I'll probably share it on the WhatsApp group as well for you guys to probably start with or probably like heads up what exactly is artificial intelligence in architecture, what are the various possibilities. See, instead of jumping right away into, let's say, the computational paradigm of architecture, I think morally it makes sense to first understand what it can do. Do you really need it or not? I think you have to have that right mindset. What do you want to fetch out of this computational learning? Until unless you are not sure of mm, what is your goal, you won't be able to derive or probably fetch much out of it. It'll just be like a skill that you have for the coding. And for the coding part, yes, it was a bit tricky, but I think with constant practice, like one component by one component, if you're exposed to it, I think Let's say I want to make a circle on Rhino, right? So it's a very straightforward component that it's like if I type circle, I can draw a circle. It'll ask me for a position and it'll ask me for the radius. Okay. Now from that circle, I would like to extrude and I would like to make it a cylinder. Then I would look, there are a couple of key terms over here. I would like to make it a like cylinder. So is cylinder a term that I can use? I'll type cylinder. Okay, it doesn't work. I would, in order to make the cylinder, I would have to extrude it. I'll type in extrude. Does it work? Yes. Hooray! I have a component called extrude. So let's try and plug that in. So I think there was a lot of permutation and combination, trial and errors that actually went to it. But once you start, I mean, the thing is, as I said, first time is always the toughest. Like to diving into that particular interface is always the trickiest bit of it. But once you are there in the interface, I think it is very straightforward. There are some of the books and some of the readings that really helped me in order to understand the right scenario or how exactly this machine learning and artificial intelligence really works. I'll definitely share that on the group. Okay. See if you can read that. I think that will help. That will give a really clear picture on what all you can do. And once you do that, because some of these books they even train you like how you should think in order to construct something. I mean, it is always about the way you construct your algorithm. You have to break down individually. So it's the mindset that really it's like, for example, you have to I have to drink this coffee, or let's say this is water there. So in order to drink it, you need to give certain set of instructions, right? I have to pick up my hand, I have to hold the cup, I have to lift it, I have to bring it closer to my mouth, and I have to tilt and I have to drink, right? That's the set of instruction that I'm giving. But as humans we are doing it subconsciously, but for in the computational paradigm I think you have to set up in. So these kind of learning methodologies are there in the books. I'll definitely share it with you guys. I hope that answers your question.
Does, man. Thank you.
Yeah. Okay. Okay. uh Okay, so how did I generate the traffic mapping? Are there any plugins there? Unfortunately, not. This was basically through. Okay, for the traffic mapping, I took a lot of information from GIS, and then I had scripted my own. I mean, there wasn't any plugins used, so this was sheer coding that went to. That was kind of an advanced level of it. There are no readily available plugins that you can use for the traffic mapping. No, you can't do that. Uh, okay, next question. Was Python used anywhere in the process of these diagrams and simulations? Yes. Uh, for some of the complex ones, let's say the diagram where I was showing you the internal working of an artificial brain that like I was created for my own research project. That was complete. It started with Grasshopper Rhino, and then it took to a state where we were using Jupyter and Anaconda. Okay, fancy words, but these are basically the platforms for coding, where we do C sharp or C plus plus, or basically Python. You can do that. So yes, it was. I have been using that.
Hi, Piyush.
Hi.
Uh, this is Prativa. I had a question. How can we use AI in order to improve the existing open spaces and parks? Like, how can we improve that place overall?
Okay. Okay. So first, I think you need to understand what exactly do you want to build there. Do you want to build something there, or do you want to take it out? So the best step would be to first quantify the environment that you're doing. Let's say I did a really small exercise about visual navigation, right? Moving from one place to another place. Check if that space, or let's say the public space that you have, is functioning well or not, with people that you have. If that is working well, see if you want to introduce any elements over there. Check the differences in the levels. If you have a sense of excitement from moving from one point to another point, if you're able to do that, yes, I mean you can definitely do it by using these kind of techniques.
Okay, thank you.
Okay. Okay, one moment. Okay, again, I would like to show you guys if let's go through some of the participant works. One second. Okay, so we have the AI Urbanized workshop. It is going to be there in from 3 weeks from now. We have the countdown already started for the registration. So if you guys are again interested, if you're keen on understanding how entire the functioning of this thing really works, go through the course. Go through how you can actually what are the courses or what are the per day division of the subjects that we have, and we have the discounted rates going on at the moment. I think it's just there for 2 days. So yeah, if this interests you, I would highly recommend you guys to enroll. If you think that you're not really exposed or well enough with Grasshopper and you need probably the beginners levels, you can definitely check uh, parameterized at Equim for the session overview. So the website is very straightforward, equim.design. We'll share it on the WhatsApp group as well and even on the Google chat. And now I'll probably take up a few more questions. I think a couple of questions, and then we'll probably be done with the session today.
Hello, Piyush.
Hi.
Am I audible?
Yeah, yeah.
So my name is Nicholas, and my doubt is that while observing all these projects developed with the help of AI, um, everything was developed based on parameters which were either user friendly or the climatic conditions. But then comparing it with the projects of great architects like Zadid or Frank Gehry, there was an extensive use of philosophy which helped them create something really great. So, is there any kind of scope of that in AI? Because I couldn't observe. I don't know if that was my mistake.
No, no, so okay, so the presentation today was mainly structured on the environmental impact of it. But if you want to understand the aspect of, let's say, human psychology and how exactly the spaces are uh, built, yes, you can do that. To answer a question, yes, you can do that. And the way that you do is basically swarm intelligence and collective intelligence. So these are again, you can do that again in Grasshopper as well. There's a plugin called Cydelium, where you can actually construct an algorithm that can understand the human movement, not just human movement, as a collective movement. Okay, and you can add in like the idea of philosophy, how the space should feel like, should be claustrophobic or it should be a bit open, how exactly you want to do it. So I think it is possible to do those
Yeah,
simulation or let's say computational algorithms as well.
yeah. Could you repeat the name of that plugin once? I couldn't.
Okay, just check for swarm intelligence.
Thank you.
Yeah, no worries. Uh, okay, could you please share the name of a few books? I will definitely do that. Soon after the presentation, I'll probably share the screenshots of the book that I have. Those are from my personal list. I will do that.
Hello.
Hi.
Hi, Piyush, can you hear me?
Yeah, very well. You're loud and clear. May I know
Yeah.
your name, please?
Shreyas, I'm Shreyas.
Shreyas. Hi, Shreyas.
Yeah. Yeah, so I wanted to ask, can you go back to that slide where you showed in a floor plan, like some office floor plan, I guess,
Yeah,
wherein you're trying different layouts. So I
yeah,
wanted to ask, with which softwares or what tools did you use in specific for that? Yes, 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 this
yeah.
for this
Uh,
particular diagram.
this is entirely on Grasshopper. This is Rhino.
Okay.
So you can create a really interesting interface using a plugin called Human UI. So you can check that, or probably you can make a note of it. So where you can actually create some interesting graphs out of it. So instead of using giving it just the numbers, you can create pie charts and stuff. And these all calculations are being done on Grasshopper again.
Oh,
So yeah,
and can you tell me the name again?
Human UI.
Human UI. Okay.
Human, like human being. Human UI. Yeah,
Okay. Thank you.
yeah. I'll quickly turn on this one as well. So we did conduct a workshop 2 months back, where these are some of the participants' entry. They were exposed to swarm intelligence as well. Uh, just looking for the right images. So a lot of students participated. Some of their entries with the work. Okay, time. Okay, I guess it's not at the moment. Probably will update the website again with those simulations and those urban analysis as well. Okay. Any other question that I can take? Okay. Would you recommend an undergrad student to do masters in computational design immediately without having much work experience? Okay. Personally, I really feel that it is if you're going for masters, or if you want to do postgrads, I worked for a couple of years in order to have a right mindset, what exactly I should do. So, but see, there's no right and wrong answer for this one. If you know that what you have to do, and if you're sure about, okay, this is where I want to get my proficiency in, be it landscape design, be it computational design, be it urban design, or be it just MArch, please go ahead right after the undergrads if you are aware of, if you know what you want to do. In my case, it was I was still in an experimenting phase. I was working with conservation, I was working with interior design, I was working with architecture, urban design, everything. So it took me a while. I decided to work for a couple of years in order to understand my forte, what I really like. Then I started reading a couple of books, which I'm gonna share, as I said. And then I had the fascination about artificial intelligence in architecture, and which is why then I was looking for a specific courses who are basically there out there who are teaching this. And I mean, yeah, if you're sure that yes, you want to do it right after your undergrads, you can definitely do that, go ahead with it. But then if you're not, if you're not really sure about where exactly you should get your proficiency in, or let's say your post graduation in, you can go for work experience. Once you're there in the field, you get exposed to a lot of different things. So I would definitely recommend that. Okay. Okay, guys. Again, there's a countdown that is going on. So if you guys are interested, I would ask you guys to check the the course structure that we have over here. What are the things that we're going to deliver and we are going to teach? And the early registration closes in 2 days. If you're keen on looking at the other workshops that are there out there, you can definitely check that in as well. Please, for someone who haven't joined the WhatsApp group with the link, we will share the link again on the chat, and do join in, because that's where I will be sharing all the pictures and the resources. I mean, we'll be sharing the resources via mail, but the pictures of the books I'll be sharing on the WhatsApp group. So just join in that, and there is a chat system available on on the website. So if you have any questions or queries or anything, please don't hesitate. Just reach out to us. If you have any questions related to today's session, uh, just type that in on WhatsApp group. If I'm free, if not at the moment, I'll take a while and probably I'll definitely revert back to you guys. So we are trying to build up a community over here. It's just not about just one webinar that we're there and then it's done. Let's stick to this. Let's try and have a really interesting and probably a brainstorming session, probably offline as well. I mean, this is what I wanted to say. Uh, Apart from that, I would like to thank you all, one and all, in fact, for your amazing participation. I think it has been a great day. I hope you guys are staying safe and well. I see there are people from different parts of the world. I really appreciate that. To be honest, I didn't expect it. I had, I mean, well, I did. But thanks everyone for being part of this. Do share your mail ID. And yeah, that's about it. Have a good day, guys.
Hello.
Uh, hey,
Yeah, I have one more question. I'm Nicholas again.
yeah, Nicholas.
Yeah, yeah. So this is not something which is completely up to the syllabus which we are following today. So that's why I kept it to the last. Um, What my question is, what kind of portfolio, what kind of skill set does it take to get into a college like Bartlett or the AADRL to learn masters in computational design?
Okay. Uh, okay. First of all, if you are willing or if you are keen on getting into some of these universities, you really need to have a really a good statement of purpose. A lot of weightage goes to that. What is the intention behind going to these universities? Even though you don't have any experience on computational learning, I think it is okay. In my batch, like when I was at Bartlett, my batch had few students who had no idea about Grasshopper and the thing, or let's say artificial intelligence or computational in general, right? So they felt it was, I mean, it was the idea, it was the intention that really matters. So even if your portfolio you're not really comfortable in adding in any of the computational projects, it's okay. Just have a well thought and well uh, executed statement of purpose. Other than that, any computational project, any parametric project, or any comprehensive understanding of computational learning, if you're able to showcase that in your portfolio, it is definitely a big plus. That's it. I mean, like one or two projects is enough out of 6 or 7 projects. You don't need to have all the projects like into parametrics and everything. That's probably too loud and out there. Just keep it bare minimum, couple of projects, one or two projects where you are introducing computational thinking. It's basically the computational thinking. It's not about how fancy your building looks, right? So the universities are going to be judging you based on this particular thing as well. This only. Yeah.
Yeah, thank you so much.
Yeah. Cheers, Nicholas. Okay, guys. I think it was a good day. Thank you all for participating. We will get back on WhatsApp and through mail. We'll share the resources with you guys soon as possible. Other than that, I would request everyone to probably leave the meeting, leave the talk, and we'll keep you posted. Thank you for your time.